Dear students, this is Murali Manohar, your maths teacher, and today the class is 10th class, Andhra Pradesh 10th class mathematics, semester 2, surface areas and volumes of solids. Solids, you know, are these are regular solids actually, and you have these only in the syllabus. Here, this is a solid, it is cylinder, and the base is a circle, top or roof is also a circle. So this is a circle, this is a circle, and this is curved surface, this is cylinder, where roof and base, they are of same shape and same size, same area. This is one solid, this is another solid, cuboid, and the cuboid you can see like this, it is length, this is height, length, breadth. So you have surface, the total base and roof, both are same. This is a prism, same. Roof and top are same, roof and bottom or base and roof are same. So these are regular prisms. For any prism, you can have another solid, and this is cube. This side is equal, length, breadth, height all are equal. This is a cube. So these solids, there is a formula for two things, a regular common formula from which you can deduce the formula for each solid. These have one surface area and the second volume. When you speak surface area, there are two surface areas here again. One is lateral surface area, sidewise. The other is total surface area, means lateral surface area plus area of the base plus area of the top. This is total surface area. For example, the total surface area means total. Suppose I want to paint this. For painting, we need total surface. Suppose I want to cover this with a wrapper. I need lateral surface. Similarly, for this, there is a total surface, means roof, bottom and total. Similarly, here it is a cylinder. Same thing, your total surface area and lateral surface area. In the case of cylinders, total surface area means curved surface area plus area of the base plus area of the roof. Here this is curved surface, this is a circle and this is a circle. So different shapes of the base give you different solids, and all of these are prisms. And for any prism, in a solids, in the case of a prism, lateral surface area or curved surface area. Lateral surface area means non-curved, it is plane, and curved surface area in the case of a cylinder, it is given by circumference of the base, otherwise the perimeter of the base multiplied by height. This height, I should not write like this because this becomes a fraction, may be confused. Let me write it as circumference of the base. This is in case of cylinder, or perimeter of the base in case of non-cylinder. This is multiplied by height. This is the formula. If you remember this formula, you can deduce the formula for any solid in case it is a prism. Now therefore, let us one by one deduce the formula for this. One is a cylinder. Cylinder, you know, it is like this. This is a cylinder and this is a radius r and the height is a h. In that case, you have a curved surface area. That's what I told. Curved surface area in the case of a cylinder is equal to circumference of the base, that is 2 pi r into height h, 2 pi r h square units. This is curved surface area of a cylinder. The second one is, for example, cuboid. And this is a cuboid. In the case of cuboid, I want to find lateral surface area. What is lateral surface area? Lateral surface area, I'll write cuboid here again, I'll draw it. This is a cuboid, and this is a length, this is a breadth, and this is height. So I am considering only lateral surface area. Lateral surface area means this surface area. So height into breadth is this, length into height this. So LH, here BH, and this L is this, therefore it is also LH, and this opposite BH. So you have LH, lateral surface area is given by LH plus BH plus LH plus BH, or you have 2LH plus 2BH, 2H into L plus B square units. So this is lateral surface area of a cuboid. Now in the case of a cube, all the sides are same size. So if I take this cube in this way, it is A into A, here A into A, here A square, here A square. So you have 4 surfaces, 4 into A square, you have 4A square. Lateral surface area is equal to A square, and the second surface, third surface, all the 4 lateral surfaces, you have 4A square square units. In the case of a square with the side A. So this is A side and this is A. Right? This is a cube. So the lateral surface area of these 3, and you can have lateral surface area of others also, but we don't consider them as we are not having them in syllabus. Right? Now the second type of surface area you have is a total surface area. And name suggests very clearly that total surface means, how do you get a total surface in the case of this cylinder? Total surface means this curved surface plus area of the base plus area of the top or roof. So this and this together give you the total surface area. Generally we find total surface area in the case of painting a solid. When you want to paint a solid completely, you must find a total surface area. Similarly, the total surface area of a cube, you paint all the surfaces. You want to paint the total surface area of this cuboid, find the area of the total surfaces, that is 1, 2, 3, 4 lateral surface plus bottom plus top or roof. So total surface area is given by curved surface area, otherwise lateral surface area, plus 2 into area of the base. Right? This is a total surface area, we say generally TSA. TSA is equal to CSA plus 2 into twice area of the base. So let us consider again one cylinder. For cylinder, the total surface area is given by TSA of cylinder, let us write. TSA of a cylinder is given by curved surface area, that is 2 pi RH plus area of the base. Base, it is pi, radius is r, area will be pi r square. So it is pi r square. So 2 pi RH plus 2 pi r square, because 2 into area of the base, 2 pi r square. So 2 pi, if 2 pi r is taken as common, h plus r square units. 2 pi r into h plus r. Next is TSA of a cuboid will be, this is a cuboid, you have LH, LH, Right, this is LH, this is LH. This is BH, this is BH. 6. These 4 surfaces. The other 2 surfaces, this is length and this is breadth. Therefore, the area of this base will be length into breadth. So, you have 6 surfaces. So, one is 2H, 2LB plus 2BH plus 2LH. 2 into LB plus BH plus LH square units. Right. So, this is the total surface area of a cuboid. Next is the total surface area of a cube is given by, already you have lateral surface area 4a square and area the base, area the top 2a square. So, it is 6a square square units. So, here you learned total surface area, curved surface area, lateral surface area of solids. Now, using these formulae, we can find the curved surface area or total surface area of single solids or mixed solids. So, mixed solids or single solids both are given as examples in your textbook. As you see, find the total surface area or curved surface area of different solids given. One solid is given here like, suppose this is a cylinder and I keep a hemisphere here. I did not tell you about sphere or hemisphere. This is a sphere. And in case of sphere, this won't stand because there is no base, there is no roof. Both are not there. It is symmetric everywhere. It is simply circular, almost like this, uniform and symmetrical everywhere. So, in the case of a sphere, the curved surface area or total surface area same, it is equal to 4 pi r square. 4 pi r square total surface area. If I consider a hemisphere, this is half of the sphere. If I consider a sphere, this is a sphere, half of the sphere is this. The hemisphere, you have two things again. This is curved surface area, half of total surface, half of the surface area of the sphere. So, this is hemisphere. Hemisphere, curved surface area or total surface area is given by curved surface area or total surface area is given by 4 pi r square divided by 2, that is 2 pi r square. 2 pi r square. Right? And for hemisphere you have two. One is curved surface area, there is also a base. And the base is pi r square. So here total surface area is given by 2 pi r square plus pi r square. It is a 3 pi r square. Right? Now, if I keep this hemisphere on this cylinder, this is a mixed solid. Suppose I want to find the total surface area or curved surface area of the mixed figure or lateral surface area. Lateral surface area, this mixed solid is given by curved surface area of the cylinder plus curved surface area of the hemisphere. For hemisphere, you know it is 2 pi r square, and for a cylinder, it is 2 pi r h. Radius is same. This is same. It is fitting on this. Therefore, this is 2 pi r square, and this is 2 pi r h. 2 pi r h plus 2 pi r square gives you the curved surface area or lateral surface area of this mixed solid. If I want to find the total surface area of this mixed solid, then this 2 pi r h, this is 2 pi r square, and here bottom pi r square. So 2 pi r h plus 3 pi r square gives you the total surface area of this mixed solid. Now the same thing if I take a cone. I did not tell you anything about cone also. I should tell you, I'll tell you therefore later on, right? Now the same thing in case I make this on a cuboid. The same hemisphere, I take a cuboid and I keep it fixed here. Right? You can have such mixed surfaces, mixed solids, and find different surface areas, whether it is curved surface area or total surface area. Fix the solids, then find the surfaces. Thereby, you can easily find the curved surface area of total surface area using this formula. Cone I did not tell you. Let me complete the cone also. For cone, this is a cone. Now if I take this as a cylinder, a cylinder can be cut into 3 cones of equal volume. So this is a cone. If I draw it differently, separately, this is a cone. Here, this is a cone. This cone, actually, if you take this cylinder, both are of same surface areas, and this is a mixed solid. Now, actually, this cylinder can be made into 3 cones of this volume and this surface area. That you can prove. Now, the cone, since it is 1/3 volume, of course, let us not speak about volumes now. If I want to find surface area for a cone, you have 3 parameters. One is the height, the radius. These two are there here also. For even cylinder, you have height and radius. But here you have extra parameter, slant height. This is additional in the case of a cone. Because here this is not a prism. Base and roof are not same. Only base is there. There is no roof. Vertex. It's only a vertex. No roof. And therefore only one. Therefore here curved surface area is this. This is a cone and this is curved surface area. And the curved surface area, this is curved surface. And the curved surface area is given by it is pi r L. And what is L? Slant height. How do you get the slant height? Slant height L, this is a rectangle triangle as you see. So L square is equal to r square plus h square. Therefore L is obtained by the square root of r square plus h square. So you know radius, you know height, you can find the slant height. Once you find the slant height, you can find the curved surface area of this cone. Total surface area of a cone is given by curved surface area plus only one base. So area of base is 1, that is pi r L plus pi r square. If I take pi r common, L plus r square units. This is total surface area in the case of a cone. Now, actually in your examination, single solids are not given. In case this is a cone and this is a cylinder, you have a mixed solid. In the case of this mixed solid, if I want to find the curved surface area of this mixed solid, it is simple. Find the curved surface area of this cylinder, that is pi r, 2 pi r h. 2 pi r circumference, height h, 2 pi r h is curved surface area, and this is pi r L, radius is same. So in the case of this sort of a figure, how do you find? You can find like now this is a cone standing on a cylinder. Therefore here the radius of the cylinder is equal to radius of the cone, same. Suppose the height of cylinder is given, height of cone is also given. Here you can find the covered surface area using pi r L. Here you can find the covered surface area using 2 pi r H. So it is pi r L and this is 2 pi r H. So the total surface area will be 2 pi r H. This I am speaking about the curved surface area, the entire solid. Curved surface area 2 pi r H plus pi r L. R is same, L will be different because the height of the cone is different. This is one mixed figure. The other mixed figure also you can have, like suppose this is a cylinder and a hemisphere surmounts this, like this. A hemisphere, it is like this, right? That is, this is a cylinder and a hemisphere surmounts this. This is easy because the radius is same. Radius is same. This is 2 pi r H and this curved surface area is 2 pi r square. So the total curved surface area will be 2 pi r H plus 2 pi r square. This is curved surface area, is the area of the entire mixed solid, right? So curved surface areas. And one more thing, suppose you are given one type of some like a capsule, a medical capsule. It is a hemisphere this side and a hemisphere this side. Both sides there are hemispheres. In that case, how do you find the total surface area? That is, it is like this. This is a mixed solid with a hemisphere here and this hemisphere this side of the same radius. So the radius is r and the length or height of this is h. This is cylinder. This part is cylinder and this is hemisphere. For this the curved surface area is 2 pi r H. This curved surface is 2 pi r square. This curved surface 2 pi r square and therefore 2 pi r square plus 2 pi r H plus 2 pi r square. Done. So 2 pi r H plus 4 pi r square is the total curved surface area, the capsule. So these are the different models and one more cone surmounted by this I told you already. Next, cylinder surmounted by hemisphere I told you. And a hemisphere, two sides, two hemispheres and a cylinder I told you. These are the three different surfaces of mixed solids you are given in your textbook. So you can, now one more example is given. Like suppose this is a square, a cube, not square, cube. In this cube, I want to make a hemisphere, cut a hemisphere like this. Cut a hemisphere. Then what is the amount of this thing cut? This you have to find in the case of volume. Or suppose you have a decorative block example number 2 given in the textbook workload example. Here it's a decorative piece. Now we want to find the total area to paint. So how do you get this? You find the total a surface area of the 4 sides and here this surface area and this area you must find. This is area. Additionally you should paint because this is a decorative piece. You cannot leave these things. To paint, make this decorative piece, you must paint these also. How do you get this area? This area is nothing but area of this surface minus the area of this circle. If I keep the circle here, this circle need not be painted. If I keep a circle here, this need not be painted. Only edges are to be painted. You can check. So the area of the surface, the square, minus area of the circle gives you the area that is to be painted here. Therefore, area of these 4 surfaces, area of this curved surface plus these two added plus area of this square minus area of this circle. This is a circle. This gives you the area of the paint area that is to be painted. This is given as worked out example number 2 in your textbook. Right? This is all about exercise 12.1. We need to do some. There is one more example given here. You can check in example number 4. Like this is a cylinder, and in this depth is cut. A hemispherical depth is cut. Mayank made a bird bath for his garden in the shape of a cylinder with a hemispherical depression at one end. This is the cylinder, and hemispherical depression, it is like this. This is hemispherical depression, that is this hemisphere going into this cylinder. In that case also you can find, your question is find the height. The height of the cylinder is given, radius is given, find the total surface area of the bird bath. Total surface area of bird bath means area of this depression. Depression is given by the surface area. So this curved surface area is 2 pi r square, and this cylinder surface area is 2 pi r h, but here you are cutting a depression, you can find this area plus this area gives you the total surface area of that is curved surface area, the total cylindrical bath. This is bird bath of this type. That's all about different mixed figures and different formulae. You can, I will tell you in the next class the different examples given in exercise 12.1 and others. Thank you very much.